Okay, we're going to be circling back around the momentum, so I want to just kind of review with you the momentum before and after charts and how to use them and all that kind of stuff that we've done with momentum. Okay, so before we start, the whole principal idea of momentum comes from Newton's first law that if for an object, unless some external force acts on it, it won't change its motion. So if it's traveling at a constant speed, it'll maintain that constant speed unless something pushes on it. Okay, well, in the case of two objects, so let's say we have two objects that are kind of moving towards each other, they're going to collide, they're going to bounce, but if we treat them as one thing, their movement is going to be centered around some place, and the way that their center is moving won't change, just like if it was one object. So, I mean, the easiest way for me to think about it is if we talk about one object moving. Okay? Well, if you split it in half and look at it and pretend it's two objects, then it's two objects moving together. Okay, so we can take any two objects and treat them, or any single object and treat it as two, or any two objects and kind of treat them as one. And the principle that we use for momentum comes from this. So anyway, in this scenario, you've probably recognized it. We have two football players that are colliding. Okay, a 110 kilogram running back that's running south at 8 meters per second. Let's say that the direction north is positive, okay? Which means if we have someone with a mass of 110 kilograms and they're running south, that would be a negative momentum, a negative velocity. Okay, meanwhile, a 130 kilogram linebacker is running a tackle and going north, which would be positive. So 130 kilograms going north at 5 meters per second. Okay, and then it says, in their collision, the linebacker wraps his arms around the runner and makes it an inelastic collision. How fast are they moving right after the collision? So what that means is, if it's inelastic, they collide and they stick. Okay? And so that means their total masses are combined together. So 110, since they're moving together, we can add their masses together. Okay? And the question is, how fast are they moving right after the collision? So that's what we're going to solve for. All right, so I want to find this velocity, and the way we do this is by using the momentum. Okay, and the momentum represents the area of these boxes. When we multiply the mass times velocity for each piece, that gives us the momentum. And the rule is, the total momentum of the system has to be conserved. Okay, on this side I'm going to write it like this, since those two masses combined and they're traveling the same velocity. So we get 110 kilograms times negative 8 meters per second plus 130 kilograms times 5 meters per second. Okay, 110 and negative 8, we multiply to find that area, is negative 880 kilogram meters per second. 130 times 5 is going to be 650 kilogram meters per second. Okay, and then the m plus m, 110 plus 130, will give us 240 kilograms times v. Alright, so I'll move this up here. Negative 880 plus 650 will give us negative 230 kilogram meters per second. And this will be equal to 240 kilograms times v. Alright, our last step will be to divide by 240. And we get about, so we divide the 240 over, those kilograms cancel, and get that v is equal to negative 0.96 meters per second. which means that after the collision, they're moving south, because south is our negative direction at negative 0.96 meters per second. Okay, so 0.96 meters per second south. Okay, we're going to look at a second example here in which two cars are colliding. If you want to take a second and read through it beforehand, you're welcome to. But I'm going to go ahead and start diagramming it. Okay, so we have a 700 kilogram car. We'll say that, let's say that east is positive. Okay, so we have a 700 kilogram car traveling east at a speed of 20 meters per second. Okay, colliding with a 400 kilogram car that's also traveling east at 10 meters per second. Let's actually change that. Let's change this right here. The 400 kilogram car, let's just say it's traveling west to make this problem a little more interesting. Okay, so let's say it's traveling west at 10 meters per second, which means it's going like this. Okay? Its speed would be negative since it's going the opposite direction now. Now, before we even begin looking at our after chart, we can already find the momentum of this system before they collide. So 700 kilograms times 20 meters per second is going to be 14,000 kilogram meters per second. Okay, then for the other one, it's 400 times negative 10. So 400 kilograms times negative 10 meters per second, giving us negative 4,000 kilogram meters per second. Okay, now we can look at after and compare it. So after the 700 kilogram car is traveling east still, but now at a speed of 12.7 meters per second. Okay, so that means that 700 times, and then we don't know what this one is yet, right? Well, that's what we want to find out. So MV plus MV. All right, so 12.7 times 700. This one has a mass of 400. Okay. So we get that this one has a momentum of about 8,890 kilogram meters per second. We can solve now for V, so we combine these. 14,000 and negative 4,000 gives us 10,000. Okay. We'll subtract this over and get about 1,110 kilogram meters per second. And 400 kilograms times V still here, and finally we'll divide the 400 over and get that the velocity of that car is about 2.78 meters per second. Okay, so it's actually going slower than the other one. So you can imagine, like, in this situation you have the one car going like this, and maybe this one's like coming next to it like this, and then it hits it as they pass. And it's got enough momentum transferred into this one that this one actually comes to a stop and then starts to go that way after the collision, and this one just kind of slows down. Okay, so that's a little bit more practice with momentum for you.